Okay, quantum mechanics, group and phase velocities. A wave is given where its amplitude and the phase of the wave is, this is the axis, y axis, that means the particle motion from the origin along the direction of what is this y, how much amplitude. So it is a times e to power I kx minus omega t. Now this is called the phase. Now this is the phase of the wave or the particle vibration, and this is the maximum amplitude. Now this is true for all waves, okay, not only for our electromagnetic waves but for all general waves this is true. Now this particular phase will be always constant. Yes.
Sir, kx minus omega t is the phase or just the omega t is the phase?
No, it's all together. Kx minus omega t is the phase.
Okay.
Yeah. Okay, fine. Thank you. All right. Now, this x, what we have written here, this is the direction of wave propagation. But right now we don't know whether it is moving along x axis, positive x axis or negative x axis, but just the direction of wave propagation. Okay. All right. Now this is the omega is nothing but angular frequency. K is nothing but wave number. Fine. Yeah. T is nothing but time. So these are the parameters that one has to identify when you are describing a wave. Okay. Now in this equation, now we know that the phase will remain constant as long as it is from a constant source. Okay. Now kx minus omega t is some constant c. Now just taking the derivative, what we get is k dx minus omega dt equal to 0, and k dx is equal to omega dt, and dx by dt is nothing but omega by k, and this is nothing but velocity. Now what velocity we will come to know? Velocity. Okay. Now what type of velocity is this? This is the velocity of the wave. That means when a wave traveling in this direction, at what time it reaches here, that will be determined by the velocity of the wave. Okay, that will be determined by velocity of the wave, that is nothing but omega by k, and this velocity of the wave I am representing by vw is also called phase velocity. Okay, because we have derived it from the phase velocity or vp. Okay, sometimes it will be represented by velocity of wave. Usually velocity of wave will come in solid state physics. Okay, SSP, but now here we will represent it by the phase velocity. Okay, now we need to know in which direction it is moving. Now dx by dt is plus omega by k. Since it is plus, we can say it is in the positive x direction. That means if this is 0, this is the x axis, positive x axis is moving in this direction. If it was negative, this wave would have been moving in the negative x direction in this way. Okay, negative stands for negative x direction. fine. Yeah. Now coming to what is group velocity. Group velocity, it is nothing but group of particle. It is just representing group of particle or group of waves. Group of waves. Okay, now group of particle direction, it is nothing but d omega by dk. Okay, that's equal to, we represent it by Vg, which is nothing but the group velocity, or sometimes we will represent it by Ve. This E represent the rate of energy transfer. Rate of energy transfer. Now this is up to here we had discussed in the previous class. Now we can have some more addition to the abstract knowledge that we had in the case of group and phase velocity. Now here is another wave that we have. E is equal to E naught sine I omega t minus kz. Now just to understand how far we have learned, we can write it's moving in the positive z direction. Positive z direction is the wave motion, and E is the amplitude. Okay, now E naught is the maximum amplitude, and here, as we know, it's moving in the z direction. We can write omega by k as nothing but Vg, Vp, phase velocity. Okay, now we have Vg is equal to d omega by dk.
Excuse me, sir.
Yes.
Sir, as you told that this is moving along z direction, how you come to that conclusion?
It's because we know that this is a constant quantity. Now once this is constant, we can write omega t minus kz is equal to 0, and here, I mean, some constant c, its first derivative will be equal to omega dt minus k dz equal to 0. Now dz divided by dt is equal to omega by k. Now this omega is a positive quantity, definitely k is also a positive quantity, so dz by dt is positive. So velocity is along z direction and in the positive side. Okay, now I hope that is clear. Now Vg is equal to d omega by dk. Now, and what is Vp? That is the phase velocity. Vp is represented by, or is given by formula omega by k. Now from this equation we can write what is omega. Omega is equal to k times Vp. Then we can write Vg, which is the group velocity, is equal to d by dk of omega by k, right? Or we can write omega as kvp d by dk of kvp, which is omega, right? Now what we can do is, you have to differentiate with respect to k. Now what you get is, we will take we will take it with respect to k first. That means k, so that will be equal to Vp plus Vp times d by dk of sorry, it's k times, because we have taken k times d by dk of Vp. Let me write it once again. It is equal to Vp plus k d by dk of Vp. So that is equal to what? Vg. Now we have another formula here. Now this is the another formula for finding out Vg. Okay, we had one formula here, and this is for Vp. Now this can be used only when Vp is a function of k. Okay, this can be used only when you have Vp as a function of k, because Vp should be a function of k. If only then you can differentiate this. Otherwise, if Vp is a function of lambda, then what is the change in our formula? That is what we are going to see. Now k is equal to 2 pi by lambda. Now that's we can write it as dk equal to 2 pi, which is a constant. 1 by lambda is minus 1 divided by lambda square into d lambda. This is the differential form. Now we just need to substitute for dk. Okay, so dk equal to minus 2 pi divided by lambda square into d lambda. Now what we are going to do is we are going to substitute this, put this dk over here and change k as 2 pi by lambda. Then what you are going to get is Vg is equal to Vp plus, now write for k what is k, that is 2 pi by lambda into its dVp, d times Vp, divided by dk is, what is dk? Minus 2 pi by lambda square minus 2 pi divided by lambda square times d lambda. Now just rearranging and cancelling out unwanted terms. That means here you have 2 pi and 2 pi, which can be cancelled, which gives you Vp. This minus will go here, so minus this lambda square and this lambda square may go up to the numerator here, which becomes which will cancel with lambda in the denominator and give you lambda over here. dVp will remain as it is, and in the denominator you have lambda. So Vp minus lambda dVp by d lambda is nothing but your Vg. Now this can be used when your Vp is a function of lambda. This equation can be used when your Vp is a function of k. So there is only very slight difference. Here you have plus and here k, here you have minus and one lambda. Instead of k you have lambda, but please remember these are very important equations. This is one, this is another, for group velocities. Okay, now this equation is the famous equation called dispersion relation. This will tell you whether a medium is dispersion medium or not. So this is called dispersion relation. Okay, now before going, let us once again write down the dispersion relation. What was the dispersion relation? It's equal Vg equal to Vp minus lambda dVp by d lambda. Okay, now air is called a non-dispersive medium. Now what do you mean by non-dispersive medium? Here if Vg equal to Vp, if Vg equal to Vp, then this is called, that means in any medium, if the group velocity is equal to phase velocity, then this is called non-dispersive medium. Okay, that means it doesn't disperse. Group and the phase velocities are same. Now let us understand for what condition this Vg is equal to Vp. Now for from this equation, that is equation number 1, if dVp by d lambda equal to 0, then you can have this particular condition of non-dispersion. Okay, now which means Vp should not be a function of lambda, right? Or Vp is independent. If Vp is independent of lambda, then only then Vg equal to Vp and the medium is non-dispersive. Okay, now this is the condition. So at this point you can write dVp by d lambda equal to 0. So this is a non-dispersive medium. Now in dispersive medium, that means in the dispersive medium, how the parameters differs. So dVp by d lambda is not equal to 0. So there can be two possibilities. One can give you positive value, another can give you negative value. That means if it is not equal to 0, there are two options. Either it can be greater than 0 or less than 0. Now if it is positive, that means Vg will be equal to Vp minus lambda dVp by d lambda. This will be the equation. Now if the dVp by d lambda is negative, that means less than 0, Vg can be written as Vp plus lambda dVp by d lambda. Now if it is positive, let me write, if it is positive, take it from this equation, that is Vg equal to Vp minus lambda by dVp by d lambda, which means you can write Vg, see it is Vg equal to Vp minus something, that means Vp is greater, so Vg is less than Vp. Now for negative quantity, Vg, here Vg is Vp plus something, so Vp will be always less, so Vg greater than Vp. Now if the quantity is positive, this is called normal dispersion. Okay, now in this case this is called abnormal dispersion. That means usually group velocity should be always less than phase velocity, and if not, in that case it is called Vg greater than Vp. That means group velocity, that means in group always it should be less than the phase, but if it is not happening like that, it is called abnormal dispersion. Okay, now in this figure there is a white light moving through a non-dispersive medium. That is why we are not able to see any distinct colors. We are not able to see any distinct color. Now once it passes through the dispersive medium, all are moving with different velocities. Okay, different velocities. Now for that reason we observe them as different colors, because they are moving with, they each have different refractive index also. Each color has refractive index because they move with different velocities. Okay. Now this is to be remembered that the first thing that you see in a prism, that the first color will be red and in the bottom it will be blue. Some interviewers may ask you when you are dealing with questions on dispersion, which color you find at the bottom of the glass. This is prism, it's not glass, it's prism. Okay, it's a prism. What color you see? It's blue in the bottom, and refractive index of blue is higher compared to red. And from moving from medium 1 to medium 2, only thing that does not change is frequency. Rest everything will change. Only thing that does not change from when a light moves from a dispersive medium to a non-dispersive medium is the frequency. Even wavelength would change. Lambda is changing. Okay. Actually we cannot say about lambda because length, it is a matter of length, that's why we cannot say that length. See, we have the formula something like this: Vg equal to what is that, Vp minus lambda dVp by d lambda, right? Now Vg, we must know, we just have to compare these two equations. Now there are two possibilities for this: either lambda dVp by d lambda can be positive or it can be negative. If it is positive, that means this lambda dVp by d lambda is positive, then we can write Vg equal to Vp minus lambda dVp by d lambda. Now if it is negative, it becomes Vp plus lambda dVp by d lambda. Now this is for Vg equal to. Now here Vg is equal to some x minus something, x minus y. Here Vg is equal to x plus y. So which is greater over here? Vg is here x minus something. So this is Vg less than this x, definitely. So Vp, and here Vg is x plus something, so it is greater than x, which is nothing but Vp. So if Vg less than Vp, that means group velocity is less than the phase, then this is called normal dispersion. Now here Vg is greater than Vp, which generally doesn't occur. That means group velocity has to be always smaller. So now it is called anomalous dispersion. Now in any case, we just have to understand whether Vg is greater or lesser than Vp. Okay, for relativistic particle, okay, we need to find out Vg and Vp. Okay, Vg and Vp. All right, now before that, let us write the energy. E square, in terms of E square, we will write E square is equal to P square C square plus m naught square C power 4. We can write it as E naught squared. Okay, now what is Vp? Vp is equal to Vp is equal to E by P. Then what we can write is this is my E, that is p square c square plus e naught square. Okay, so that is my root of e square is e divided by p. Okay, let it be like this, and this must be my first equation. Now we need to find out the group velocity, dE divided by dP. Now what is E here? E is equal to under root p square c square plus e naught squared. Now root x derivative is 1 by 2 root x, and what is the x? X is nothing but p square c square plus e naught squared, then into dx, right? Root x derivative is nothing but 1 by 2 root x into dx, right? And what is the derivative of x? Means what is derivative of inside the this inside the root, whatever derivative is there, you have to take it. Okay, now with respect to what? With respect to p, so that is equal to 2 times p into c square. That means root of this quantity I have to take. So 2p c square. Now this 2 and 2 you can take it out. Now what is remaining is p c square divided by under root p square. Now the question was find Vg times Vp. Okay, before going to this anomalous dispersion or normal dispersion, we'll just find out what is Vg and Vp. Now Vg dot Vp is equal to, this is your Vp Vg. Now root of p square c square plus e naught square. In exams you don't write the entire terms, you just write root of some x. Okay, just to save the time, by p into pc square divided by under root. Again, don't write all the quantities. If you can keep in mind what is root x, just keep those in mind and do. So Vg dot Vp is equal to c square. Okay, now we have got Vp is equal to under root p square c square plus e naught square by p, and you have another quantity Vg, which is equal to pc square divided by under root p square c square plus e naught squared. Okay, now just multiply this with the denominator here into root. Okay, so that becomes p square c square plus e naught square divided by p into under root p square c square plus e naught square. And Vg you will have, Vg is equal to, you just have to multiply by p, so p square c square divided by p into under root p square c square plus e naught square. Now can you tell me which is greater? This is your Vp, so
Vg is greater, sir.
Vp is greater than Vg, which means
Yes.
it's a normal dispersion. Now here underline every important point. It is particle of rest mass m0 is moving straight line with the relativistic velocity. Now we are considering it as a relativistic particle. Now Vg we don't know, Vp we don't know, but we know the particle is moving with particle. Now particle is moving with, now Vp is the phase velocity, okay, Vg is the group. Now group velocity is also called particle velocity. Okay, group of particle motion is nothing but the particle or group velocity or phase velocity, group of waves. Okay, so Vp is equal to beta c. Now for relativistic aspects, we can write Vg into Vp is nothing but c square. Now once we already have Vg, so Vp is equal to c square divided by Vg. Now that's equal to c square divided by beta c. That's nothing but c by beta. That is Vp equal to c by beta. And what is Vg? Vg equal to beta c. Now here also you can find out whether it is normal dispersion or anomalous dispersion. So Vg is equal to beta c and Vp is equal to c by beta. Now beta value is always less than 1, which means your Vp is greater than Vg. So this is corresponding to normal dispersion. Yeah, for a wave in a medium, the angular velocity omega is given as omega wave and the k are related as omega. Okay, fine. Yeah, so omega is given. We will immediately write omega is root of omega naught square plus c square k square. Okay, so first thing that we can get is Vp, which is equal to omega by k, that is nothing but omega square plus c square k square by k. Okay, that is the first part. Now Vg is equal to d omega by dk. Now root we can write it as 1 divided by, don't write 1 here, okay, just divide it by 2 root of omega naught square plus c square k square. Okay, then its derivative should come, derivative right here. Okay, that's how proficiency increases. You understand the importance of 1, right? Irrelevant when you are going to write something in the denominator. So immediately write the denominator and start writing the numerator part. So this is with respect to k, so I can write 2.
Sir, is it c square?
2c square k, yeah.
Yes, I got it, sir.
Yeah, fine. So 2c square k is the answer. Now we have we need to find out Vp dot Vg, right? Vp into Vg. You can also cancel out these two k's. So root of, now I am writing some x divided by k into c square k divided by root of something k. Okay, or x, root of some x. So x get cancelled, k get cancelled, it gives you c square. Now Vg into Vp is c square, so you can almost write it is a relativistic particle if provided they asked about this. Otherwise you can just write down what is Vg into Vp. If they are asked about the comment on the velocity of the particle in the medium, just if you write comment, then you need to mention about the relativistic quantity, otherwise not. Yeah, relation between omega and k is given by omega square is equal to gk plus a k cube. Now omega is given, we can write omega by k, which is the um, group velocity. Sorry, it is Vp. Group velocity we don't know. Vg is equal to d omega by dk. Okay. Now what is Vp? So it is root of gk plus ak cube divided by k. Now need to further simplify. Let us see and do the simplification only if it is necessary. Now d omega by dk is again 2 root gk plus ak cube, and the denominator of this with respect to k, g plus 3 a k square. Now the question it is given the group velocity is equal to phase velocity. That means root of gk plus ak cube by k should be equal to g plus 3a k square divided by 2 times gk plus ak cube. Okay, now just bring this here. So what you are going to get is gk plus ak cube is equal to, then multiply here and you will get 2 times gk plus ak cube equal to gk plus 3 times ak cube. So 2gk plus 2 times ak cube equal to gk plus 3 times ak cube. Now 2gk bring this here, so it becomes gk, and bring that to the next side, that is ak cube. Now k and k square you can remove, so this is k square. Now k square is equal to g by a, or k is equal to root of g by a. Now let us put that equal to k naught. K naught value will be equal to root of g by a, such that group and phase velocity Vg equal to Vp. Now for Vg equal to Vp, k is equal to k naught. That's the idea.